All right, friends, let's go ahead and implement the permutation with repetition, the video that we looked at last. In the last video, we discussed that. So we give ourselves test permutation function. It's going to be called from main, and our input string is ABC as we have here, and our subset size is 3, like we have here, n equals to 3, and k is also equals to 3, right? And we want to store the result into the vector of strings, right? So, and then we call this our perm rep, which is permutation with repetitions. So let's go ahead and implement it. So this is going to return vector of strings, and it's called perm rep, and it's going to take a string reference as an input and subset size. All right. So that is our main function, the function that's going to run the permutation repetition. But we need to store the partials, and we need to store that in a vector of string, right? So we will give ourselves a helper function, which is perm rep helper, which is going to be our recursive function, and this is going to do the actual recursion for us. So what are the parameters for this function? Well, obviously, the first things that it would need is the original string and what's the subset size, because our end condition for recursion is when the partial string becomes the size of the subset, then we want to store it. Okay, so let's give ourselves a partial string, which would be empty to begin with, and then we'll uh, collect variables or collect characters from the input string and put that in. And then we need to give ourselves a vector string, and that would be the result, right? So it needs two other parameters, partial, and it needs a result, right? And once it is done, then we're going to return the result back to the caller. All right, so now we need to define our recursive function, which is the perm uh, rep helper. Okay, so we know the parameters that it takes as input, the input string s, and the subset size k, and then we need to pass in partial, and we need to pass in the vector of string that we want to maintain to the results. Now, just if you pay attention, we're passing partial by value, so that the value will be stored on the stack, because we want to store partial values every time we call into the recursive function, whereas the result is passed by reference, because once we are done with an iteration, we want to store that and we want to retain that. So as the stack rolls and unrolls, the partial values are going to be either AAA, or it will be rolling back to AA, or it will roll back to A, because that is what we had stored on the stack. So you will see as we go forward. So now, what's our termination condition for this? So our termination condition is if partial has collected enough elements that satisfy our subset size, then go ahead and store that, right? Uh, so go ahead and store that. So we are going to store that to start vector back partial to that, and then we want to return. So we'll be done with the branch, right? If you see that once we have collected this, once we have collected this, and we've collected this, then this branch is done, right? This particular branch. Okay, so going back, here we have our main for loop, which runs every time from starting index 0, and it has to be less than the size of the input, and we keep incrementing the index. So, and then we call this function perm helper or perm rep helper recursively, right? So pass in s and pass in k. Now at every point we are building up, as we partial. We want to build up the partial, and the first thing that we want to collect is the element in index I, and then we're going to pass in result. Right? Okay, so let's take a look at the entire call flow. So we have this perm helper, which is giving us a partial, which is empty to begin with, and then we have a result, and then we call that. So initially, the string is empty, and the size is 3, and the result is empty too. So partial of size will be 0. So then we don't return from here. We come here, and then it's going to say, okay, I'm going to call myself again, and I'm going to store in partial the first element out of this string. So what is the first element, which is a? So we pluck a out of this string, which is this a, and we store that in partial, and then we call ourselves again. So for the partial size is still not 3. Partial will at this point will have just a, and then we call ourselves again, and then we say that okay, from the input string, give us the first element. So now partial will be added another a, and same thing happens again. It's added another a. So we added 3 a's, and then after the third a is added, we're going to check, oh, partial size has reached the size of our subset. It meets the requirement, store and return. So once this is done and it's called again, it'll store triple A and then it'll return back, right? So it'll return back to this condition. Now, once it returns back, what we were doing at that point, we had added what was there at s of I. S of I was 0, right? So now this for loop will go ahead and it will increment I, and it'll say, okay, the partial right now is AA, and add the first element to that, or the second element, sorry, because I is incremented. So partial is AA and add B to that. So I would add B, and then we get AAB. And if you follow the trend, you should see how it's picking up every element when the stack rolls and unrolls. So this will add B to AA, this will add C to AA, and then the for loop would have already executed, for the s of size, which is 3, and then this for loop will return back to the previous one where we would have just added a to it, and we would go ahead and add b, and our partial size would become 2 now, and then we'll repeat this abc again. So let me go ahead and run this, and we'll see how it gives us the output as we expect. So call make on make, and let's call my target AC. So like you see here, if you follow, we have AAA, which is what we wanted as the first one. So AAA, and then this is where we continue on the left branch. And then we said, okay, AA, you have incremented the index. Now we are going to collect B. So we collected B, we got AAB, and that was the size. And then we said, okay, AA, the for loop proceeds and it goes ahead and gets the index at the third position, the element at the third position, and that's C. So AA is giving us 3 unique subsets, right? AAA, AAB, AAC. If you see that, these are unique in the sense there is no other AAA, right? So that's why the uniqueness. But the same A is repeated, right? So A is repeated again here, A, and can be repeated again here. So yeah, do post in comments if you have or any questions. I would be happy to answer them, and that we would look at combination in the or permutation with no repetition in the next video.